Lesson 7-1. Apply the Pythagorean theorem. By the end of today's lesson, we will be able to successfully find side lengths in right triangles. The Pythagorean theorem. The Pythagorean theorem states that in a right triangle, the square of the length of the hypotenuse, so right here we have C here represents the hypotenuse. If we take the square of this, which is C squared, it will equal to the sum of the squares of the side lengths of the legs. So A squared plus B squared. I have given you a proof on my website. So if you could take a moment to go to the website and look at the proof. Example 1. Find the length of the hypotenuse of the right triangle. So part A, we're given the side lengths of the legs. So we just take the square, 24 squared plus 7 squared. This would equal to x squared. And then when we do the math, 24 squared is 576. 7 squared is 49. Then we add it together, it's 625. So x, which is equal to 25, which is very simple. Just apply the formula. And then part B again, let's give one practice. 9 squared plus 12 squared would equal to the hypotenuse, x squared. So 81 plus 144, this would go to 225, and x would equal to 15. In example 2 here, they would like you to use the Pythagorean theorem in a real-life situation. Part A, a 6-foot board rests under a doorknob, and the base of the board is 5 feet away from the bottom of the door. Approximately how high above the ground is the doorknob? So 6-foot board, this is the 6-foot board. It rests under a doorknob. So here's the doorknob, and it's 5 feet away from the bottom of the door. So we want to find the height from the doorknob to the ground. So we let that be x. So now we have 5 squared plus x squared equal 6 squared. So then we have x squared equals to 36 minus 25. And this would be equal to 11. And we just simply take the square root and be square root of 11 feet. Well, the problem asks you to approximate. It's okay, just leave your answer in simplest radical form. Okay, part B. A 5-foot board rests under the doorknob, and the base of the board is 3.5 feet away from the bottom of the door. Approximately how high above the ground is the doorknob? So the scenario changed here. Instead of having a 6-foot board, we have a 5-foot board. And it's 3.5 feet away from the bottom of the door. So this were the door. And here's the doorknob. Then how high above the ground is the doorknob? So we can let this be x. So this will be 5 squared equal to x squared plus 3.5 squared, and this will be 25. And then x squared would be equal to 12.75. Then x, we'll just take the square root and just simply leave your answer like this. Example 3. Part A. Find the area of the isosceles triangle with side lengths 16 meters, 17 meters, and 17 meters. Alright, so first of all, we need to find h. We can set up the equation as 8 squared plus h squared equal to 17 squared according to the Pythagorean theorem. And we work this out, then h squared would be equal to 225, and h would be equal to 15. And then we have to find the area of this triangle. So we simply take half times the base, which is 16, and times the height. So that'll be 120 meters squared. Okay, let's take a look at another problem here. In part B, we find the area of the triangle again. So I'm going to let the height be h. And look at the base here. I'm going to take half of 28 and make that 14. And then I'm going to simplify this. And I see a Pythagorean triplet, which is 7, 24, 25. But I'm going to work that out for you just to show you. 7 squared plus h squared equals 25 squared, 49, 625, h squared equals, we have 576, so then that h would equal to 24. And then we have to take 24 and multiply 2 back, because we divided by 2 here. Don't forget that, otherwise you'll get the wrong answer. So the area will be half times the height of 48 times the base of 28. So 48 times 14, we have 117 square feet. Common Pythagorean triples and some of their multiples. The most common Pythagorean triples are in bold. So we have 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. If you have these triplets memorized by heart, it will make your life easier. And the other triples are the result of multiplying each integer by a bold-faced triple by the same factor. So here, let's take for example, if we have 3, 4, 5, if we multiply by a factor of x, so x can be any number, like 2, for example. So we take 3 and we multiply by 2 to get 6, 8, and then 10, 4 times 2, 5 times 2. So this is times 2, and this is times 3, and this will be times 10. So if we look at example 4 here, part A, find the length of the hypotenuse of the right triangle. Well, we can simply use the Pythagorean theorem, but these numbers will be very big, so it would be wise of you to first simplify it by their greatest common factor. Let's see, for 24 and 45, the GCF should be 3, so divided by 3 is 8, divided by 3, we have 15. So if we go and look at your common Pythagorean triplets, 8, 15, 17. So x should be 17 times, because we divided by a GCF of 3, I have to multiply by 3 back, so that makes 51. So x here is 51. And if we look at the second example here, we have 30 and we have 40. Well, I don't want to work with such big numbers, so I could first divide by the greatest common factor of 10. So it would be 3, 4. And then for x, 3, 4, this should be 5. A common Pythagorean triplet. I need to multiply by 10 back. It'll be 50. Okay, and then we will continue the lesson in class.